it is only a monochromatic. That means, what do you mean by monochromatic? Mono means single and chromatic means color. That means it is of a single color. That means if it is a green, it will be green. If it is red, it will be red. It will not be participated into different colors or divided into different colors, because due to having a single, the spread over a single wavelength, that is up to the range of 1 nanometer, which is very small or which is very narrow. So this is one of the question which was asked for 4 marks. Let us move towards the next slide, which is the second question of the question paper, question 2A. Here in this diagram you can see the monochromatic color. Now let us move towards the next question, question 2A. This question is asked for 5 marks, or nearly about 3 to 5 marks, in the range of 3 to 5 marks. In June-July 2011 it was asked for 5 marks, and this question this numerical or this sum is asked for 5 marks from the chapter of acoustics, or I can say architectural acoustics. A hole has a volume of 13,000 meter cube and reverberation time 1.6 second. If 300 chairs are additionally placed in the hall, what will be the new reverberation time of the hall? With respect to that, the quantity which is given is absorption of each chair is 1 OWU. OWU means open window unit. So this is one of the question of reverberation time which is asked from the chapter of architectural acoustics. Let us calculate this question. In this question it is asked that calculate the new reverberation time if 300 chairs are additionally placed in the hole. The volume of the hole is given 13,000 meter cube, as well the reverberation time when 300 chairs are not placed inside the hole, that is 1.6 seconds. I repeat, the reverberation time given in the sum is 1.6 second, which is the reverberation time when 300 chairs were not added inside the hole. An absorption of each chair is 1 OWU, that is open window unit. Let us calculate this sum and move towards the slide. Here you can see that V is the volume of the hole and T is the reverberation time. The volume of the hole is 13,000 meter cube, as well as the reverberation time is 1.6 second. 300 chairs are additionally placed. So that means if 300 chairs are additionally placed, then the next reverberation time, that means the new reverberation time, will be T2. Here you can see that T1 is the old reverberation time, when that is 1.6, which is equal to 0.167 V upon summation of AS. 0.167 multiplied by V is the volume of the hole, as well as summation of AS is the total absorption. So this is the equation which you should place when it is asked for reverberation time. Now T1 is given, that is 1.6 second, and summation of AS, that is the total absorption, it is not given. V, that is the volume of the hole, it is 13,000 meter cube. Now, when I calculate summation of AS, that is the total absorption inside the hole when the reverberation time is 1.6 second. Now, when I calculate summation of AS, this T1 goes in the denominator. That means 0.167 multiplied by the volume of the hole, that is 13,000 meter cube, divided by 1.6 second, that is the reverberation time. When I calculate and solve this, I get the answer of summation of AS, that is 1.1356.875, that is Sabine meter square. Here A is Sabine, or A, that is the absorption is calculated in Sabine, multiplied by S, that is the surface area, which is calculated in meter square. That means summation of AS can be measured in Sabine into meter square. My dear friends, unit should be kept when you are calculating a sum. This is the answer of summation of AS, that is the total absorption. We want to calculate this T2, that is the new reverberation time. Now here what happens, if 300 chairs are additionally placed, and before 300 chairs are additionally placed, the absorption was 1356.815. Now what will happen, that if we want to calculate T2, here you can see in our slide, here the next equation is T2, which is equal to 0.167 into V upon summation of AS, which was the older absorption before 300 chairs were not added. When 300 chairs are added, the absorption or rate of absorption or total absorption by the 300 chairs is also added with the absorption. That means the new equation will be, or the new reverberation time will be T2, which is equal to 0.167 V upon summation of AS plus A1 S1. To calculate A1 S1, here you can see that A1 S1 which is equal to A1 AS1 plus AS2 plus up to plus AN SN. Now here you can see that we are adding 300 chairs. That means AS1 plus AS2 plus up to plus A300 S300. Here the surface area of chairs are not given. That means the one chair is concluded as one surface area. That means 1 OWU multiplied by 1 plus 1 OWU multiplied by 1. And this multiplication of 1 and addition with another multiplication will be 300 times. That means A1 S1 will become 300 Sabine meter square. So in this equation we calculated summation of AS and we are adding A1 S1, that is 300. So by substituting the equation, 0.167 multiplied by 13,000 meter cube divided by 1356.875 plus 300. So in denominator, here if this absorption increases, this reverberation time will decrease. That means when I am adding this 300 chairs or 300 surfaces more, the absorption increases and the reverberation time decreases. That is, when I calculate, I get the answer 1.31 second. That is T2, that is the new reverberation time, and it will be 1.31 second. As we can say that T1 is 1.6 second. When 300 chairs are additionally placed, the reverberation time decreases due to increase in the absorption when it is getting added to the first absorption. That is, the new reverberation time decreases up to 1.31 second from 1.6 seconds. So this is how we calculated the first sum from architectural acoustics, which was asked in June-July 2011 for 5 marks. Friends, through this equation you can easily solve this sum, whether it is 300 chairs or 200 chairs or 500 chairs, if additionally added, to calculate the reverberation time or to calculate the absorption or total absorption or average absorption or surface area or volume. You can calculate any according to the data given. Now let us move towards the next question, that is question 2b. According to our slide, here question 2b is, what is acoustic grating? What is acoustical grating? This question can be asked in 5 marks in detail, but this question is asked to just explain that what is acoustical grating, and this question is asked for only 2 marks, and it is the most important question which can be asked for 2 marks in your general exams of GTU. Now let us move that when ultrasonic waves are passed through a transparent liquid medium in a container, the wave gets reflected. The reflected waves are called echoes. I can say that ultrasonic waves is having the properties to reflect back as an echo when there is an obstacle. That means when ultrasonic waves are passed through a liquid medium in a container, the wave gets reflected from the bottom of that liquid medium. The reflected waves are called echoes. The directed waves, which is the sending waves, and when these waves get reflected, that means the directed waves and reflected waves superimpose to form a stationary wave pattern. That means the sending waves and reflecting waves, when these both waves superimpose on each other, it forms a stationary waves. So in acoustical grating, what you need is to explain that ultrasonic waves are having or are called the reflecting waves, which are called echoes, and the next thing is when sending waves and reflecting waves are superimposing on each other, they form a stationary wave pattern inside any medium. Let us move to the next slide. This wave gives rise to periodic variation in the density of the liquid. Due to the molecule of these waves, or due to the small particle of these waves or motion of these waves gives rise in periodic variation in the density of liquid. That means this change in density of the liquid leads to the variation in the refractive index of the liquid. That means at different points the density will be different. In the stationary wave, there are 2 points which is being generated in a stationary wave pattern. One is nodal plane and another is antinodal plane. Here you can see in the third point that the density of the liquid is maximum at the nodal plane, while at the antinodal plane it would be minimum. That means such a liquid subject, ultrasonic waves, behaves like a grating. That means when the light, under this condition, if a parallel beam of light is passed through the liquid at right angle to the wave, the liquid acts as a diffraction grating. That means when a light is passing in a perpendicular direction to the liquid medium will behave as a grating, and on the next screen a diffraction pattern can be generated due to difference in the refractive index due to a periodic variation in the density of the liquid. Such a grating is known as acoustic grating. So this must be the proportion to explain the acoustical grating for 2 marks. Let us move towards the next question, which is question 2C. Explain the principle, construction and working of magnetostriction method of producing ultrasonic waves. Here we will explain the principle, construction and working of magnetostriction method to generate ultrasonic waves. Magnetostriction method is one of the methods through which you can produce ultrasonic waves. The magnetostriction method is working on the principle of magnetostriction effect. First of all, in this question, you should write the principle, that is magnetostriction effect. When we see on the slide, here you can see that principle. First of all, let us concentrate on this diagram, which is representing the magnetostriction effect. Here in the center, there is a ferromagnetic rod which is placed between the magnets. This is the ferromagnetic rod, and these are the 2 magnets between which a ferromagnetic rod is placed. When this magnetic field is applied parallel to the length of this rod or this ferromagnetic rod, this rod will start contraction and rarefaction. That means contraction and expansion. This ferromagnetic rod will contract and expand under the effect of magnetic field which is